Hello dear students and welcome back to another episode of the chapter Electromagnetic Induction. Now in this today's video we are going to discuss about the concept of self-induction and mutual induction. Before starting that, one should know about the concept of electromagnetic induction. From Faraday's experiments we have seen that if suppose there is a current carrying coil, okay, and say this current carrying coil is kept near another coil, something like this. Then if there is change in the current in this first coil, okay, this is we can say that able to bring the induced current in this second coil. Okay. So this phenomenon basically is referred as induction. Okay. Now first we have to discuss here what is the meaning of self induction, and later on we will discuss about the concept of the mutual induction. So let's start. Let us discuss first of all about the concept of self induction. Self induction is the phenomenon of inducing EMF in the self coil due to change in current and hence the change in magnetic flux in the coil. For example, say this is the coil, and say in this coil some current I is passing, something like this. Okay. Now what happens here, when the current I is passing in this coil, that time the magnetic flux which is linking with this coil, it is changing, and as a result of that, along with this conduction current, what happens here, an induced current is also produced here, but this induced current will oppose the rise in this conduction current. So let us say that I dash is the induced current and it will be in the opposite direction. It will try to oppose the rise in this current I. So as long as the current is changing, this induced current will be produced there. One stage will occur when this current will reach to the maximum value, and then finally this I dash will be vanished. It will be stopped. So this phenomenon in which the current is passing in the coil and induced current is also induced in the same coil is called as the self induction. Okay. Next, the induced EMF opposes the growth or decay of current in the coil, and hence always it delays the current to acquire the maximum value, as I have said earlier. Okay. If the current is say falling down, in that case also it will oppose, and when the current is rising, in that case also it will oppose. Now self induction is also called the inertia of electricity, as it opposes the growth or decay of the current. Now there is a factor called as self inductance. Be careful about self induction and self inductance. Self induction is the phenomenon of inducing current. Now what is this self inductance? How it is defined? Generally, the phi, that is magnetic flux, is directly proportional to the current I, or if I write it in terms of equation, I can say that phi is equal to constant L into I. Now here this L is called as the proportionality constant, that is it is called as the coefficient of self inductance or coefficient of self induction. So phi is equal to L into I. Let us try to define it. If I take I is equal to 1, then what will get? We will get L equal to phi, right? So from here the self inductance is defined as the magnetic flux linked with a coil when unit current flows through it. So that is the meaning of self inductance. Be careful about, just like resistance, capacitance, there is inductance. We are talking about the self inductance here. Okay. So it also offers one type of say opposition. And what is that opposition? It try to reduce the current when it is increasing, and it try to increase the current when it is reducing. When I am saying about the currents here, I want to talk about the conduction current delivered by the source of EMF, and second is the current which is due to the induced EMF, right. Further, if I want to define, I can write here E equal to, that is minus d phi by dt as per Lenz's law, or I can say that E is equal to minus L di by dt. This I am taking from here. Okay. So, from here also we can define the concept of induced EMF as well as the inductance. So, if I take di by dt is equal to 1, then L will be equal to E, where E is the induced EMF. Thus, we can define self inductance as the induced EMF setup in the coil through which the rate of change of current is unity. So, in this way we can define the concept of self inductance. Self induction is the process and self inductance is the coefficient, or that say property, which try to oppose the change in the current, right. The SI unit of self inductance is Henry. It is taken as capital H. Self inductance is said to be 1 Henry when 1 ampere current in a coil links magnetic flux of 1 Weber, or self inductance is said to be 1 Henry when unit rate of change of current, that is 1 ampere per second, induces EMF of 1 volt in the coil. So, in this way we can understand about the concept of self induction and self inductance. We have to talk in our next video about the concept of mutual induction and mutual inductance. So, watch the next video on mutual induction.